Hi everyone, it's Coach Brett here. So today I'm going to be talking about zeros from a graphing calculator and vertical motion problems. We've actually been doing vertical motion problems, but I've been giving you most of the equations and I'm going to teach you how to write your own. But today let's look at what we've been doing. So we've been finding the zeros of a quadratic function, which remember are when we solve a quadratic equation. Okay, we solve a quadratic equation, we're either finding the zeros, the roots, or the x-intercepts. So a quadratic will always have roots. That doesn't mean that those roots will be x-intercepts, because remember, if we get an imaginary root, then it's not going to cross the x-axis, so it wouldn't have an x-intercept. But let's talk about those methods. So we can solve a quadratic by graphing, okay, with our calculators. So when would I use that? Well, I actually could use that at any time. I tend to use it when estimates are okay, all right, so when estimates are okay. Or I tend to use it if it looks like it's going to be a really involved question and I just need to have a general sense of what the root is, or a decimal representation would be fine for the root. And if a calculator is allowed, okay? What's an advantage of using your calculator? Well, it's quick and easy, right? It's quick and easy. Well, a disadvantage is you got to know how to use your calculator. And so as a reminder, you enter the function into your calculator and the y equals, and then you go to your zeros. You find your zeros. Okay. All right, factoring. Factoring is another method that we would use. I use it to solve a quadratic if it's in standard form of any kind, and I use it first. Okay, it's the easiest. I always try it first. It's the one you've spent the most time on. So if it's factorable, I'm always going to, if it's a quadratic equation, I'm always going to try this first, and usually pretty quickly I'm going to determine it's not factorable, then I'm going to move on, okay? I hate saying that it's the easiest algebraic approach, but that's usually it is, okay? So maybe I'll write that. It's the easiest algebraic approach. Especially right now because you guys have been practicing factoring for so long and you're really good at it. So we always want to try factoring first. All right, the square root method. The square root method, we want to use it when the linear term is missing. So meaning you like have x squared equals a number, or x plus 2 squared equals a number. If it's in those forms where the linear term is missing, then I'm going to use the square root method. Why is it easy? Well, because you don't have to find factors. You just have to isolate the square. Isolate square and then square root. So it's actually it's another easy way to solve something. Completing the square. Okay, so completing the square in the quadratic formula we're going to use when it's not factorable. When not factorable. But I will say that I'm only going to complete the square if two things are true. If A is equal to 1 and if B is even. Okay? The reason I like completing the square is because it's easier to simplify than the quadratic formula, right? It's easier to simplify than the quadratic formula. But some kids don't like completing the square. I'm okay with anything. I just want you to have lots of options for solving a quadratic equation, okay? Quadratic formula for me, when to use, if it's not factorable, okay, so when not factorable, and to me it's a last resort. Why? Because there's so much in the quadratic formula that has like, you've got square roots, you've got squares, you've got negatives, you've got fractions, all these things that you can make a mistake with. What's an advantage? Well, it always works, okay? It always works. So that is definitely, okay. When does a quick sketch of a graph help, okay? Well, a quick sketch of the graph always helps me when I'm doing word problems because it gives me an idea of what's happening in the situation. So I know when I'm writing my quadratic equation that I have a sense of like where the graph might start, is it going up or down. So today we're going to actually look at real world applications of something of quadratics using vertical motion. Vertical motion is when I throw something vertically into the air or up in the air, okay? All right, so there are two different models that we use. Well, they're the same but different models that we use for vertical motion. And we've been using these models, but I've been giving them to you. And now we're going to use the model and write our own, okay? So the first model is h of t equals negative 16 t squared plus v sub 0 t plus h sub 0. Negative 16 t squared, you'll see it, negative 16 is a constant and is related to gravity, because gravity is actually 32 feet a second. So the formula really is negative 1/2 gt squared, but we simplify it by making it 16 because 1/2 of 32 is 16. V sub 0 is the whatever you're throwing, it's initial vertical velocity. Okay, initial vertical velocity. And that's why we say V0, initial, that means initial. H0 is the initial height in feet, okay? We call that the y-intercept as well. And so if we think about the graph time is always going to be on the x-axis and height will always be on the y. So it could be something like this, it could be something like this. Now, this model is when the equation's talking about feet per second. The second model, okay, the only difference is negative 4.9, okay, and that's when it is in meters per second, and that's because gravity in meters per second is 9.8 meters a second, okay? All right, so we've got two models. We're going to be working today with the one that's in feet, but I want you to know that meters is also one that we might look at, okay? So let's look at an example. A soccer ball is kicked from the ground level with an initial velocity of 32 feet a second. After how many seconds will the ball hit the ground? Well, the first thing I want to do is a quick sketch of what's happening. So I know that it's a vertical motion problem because something is being kicked into the air and it's going to go up and down. So I know that my time is along the x-axis. I know that my height is along the y-axis. It says it's kicked from the ground level, so I know that h sub 0 is equal to 0. My initial velocity is 32, so I know v sub 0 is 32. Okay? The graph starts on the ground, the ball goes up, and then it goes down. All right, so when it says after how many seconds will the ball hit the ground, it is actually asking you for the x-intercepts. Now, we already know one of the x-intercepts because that's the starting value right here. So we're specifically looking for that x-intercept, but we don't have an equation, so now we're going to use our model. Our model, h of t equals negative 16 t squared plus 32t plus 0, okay? That's the model. Now, because I'm looking for the x-intercepts, I'm going to set h of t or y equal to 0, and I'm going to solve. Okay, well, this is a quadratic equation, so I have to figure out what my best method would be. So I always start by factoring. In this case, I can factor out a negative 16t. It's GCF factoring, and I'd be left with t plus 2. I'm sorry, t minus 2. I now use the zero product property, and I set each factor equal to 0. So t is equal to 2 and t equal to 0. The first one we already know, so this one would be 2. So the answer would be after how many seconds will the ball hit the ground? 2 seconds. Okay? All right, let's try another one. Marilyn hit a golf ball on the ground. Marilyn hit a golf ball on the ground with her driver. Use the general function for a projectile to write a function that shows the height in feet of her golf ball as a function of time. The ball was hit with initial velocity of 100 feet per second. So V0 was 100. H0, because it says ground, was 0. So my equation, and it's feet per second, so I know I'm using that model. H of t equals negative 16 t squared plus 100t plus 0. Okay? How long will Marilyn's ball stay in the air? I have a general sense of this. I've got my time and my height, and the ball went from the ground up. And so this is going to be, how long will the ball stay in the air? How long is time? It will be in the air this whole distance. So I'm looking for that value, which is the x-intercept. So once again, negative 16 t squared plus 100t equals 0. So I'm going to solve by factoring. Now you could, I factored out a negative 16 in the last one. I could simplify this, okay? I could simplify this by dividing everything by negative 4. Remember, you can't divide by t. That is one way of simplifying it, so I want to show that way as well. So that would give me 4t squared minus 25t equals 0. And so now I can take out a t. So that is another method of doing that. Apply the zero product property. So t equals 0 and 4t minus 25 equals 0. So t equals 25 over 4. So that's about 6 1/4, so 6.25 seconds. And so that's how long the golf ball would be in the air. All right, now each of these examples I asked for the x-intercept. It's not always going to be like that. And it's not always going to start on the ground. So you have to be really cognizant of that, okay? A rocket's launched from the ground with an initial velocity of 144 seconds. So you should be able to write this equation right now. So go ahead and write it, press pause, and then come back, okay? All right, so if you pressed pause and you wrote your equation, you would have had negative 16t squared plus 144t. Okay, so one equation is I can ask, well, when is this rocket going to be at 320? So this is saying, when is h of t going to be equal to 320? So in this situation, you would set the equation equal to 320. Okay? All right, and then you'd solve. Now, looking at this one, this is an ugly equation, right? So I'm going to try and simplify, and this might be a really good one to try with your calculator. Okay, so if I was going to use my calculator, I would first want to get it into standard form by subtracting negative 16t squared plus 144t minus 320. Okay, equals 0. So now I have a quadratic equation, and I'm going to ask you to try and get your calculator, try and solve for t with your calculator. Press pause, and I'm going to go over it, just to make sure everyone's got this clear, okay? All right, so you're back. You should have gone to your calculator, and you should have put in your y equals negative 16x squared plus 144x minus 320. You want to be really sure that you know that you can only use x for the calculator. Also, the negative 16, you have to use this button next to the enter on the left side over here, okay? So make sure you're using that negative and not the minus. Otherwise, you're going to get a problem. So to find the zeros, I'm going to go to I'm going to press second, trace. I'm going to calculate the 0. Okay, so I need 2 zeros. So now remember, it's going to ask me left bound, so I want my arrow to be, I want to be on the left side of the 0. I don't see where is it? Hold on, is it coming up here yet? All right, there we go. Okay, so I want to be on the left side of the 0, so anywhere to the left side about there. I'm going to press enter. I'm going to do that again. Go to the right side of it, press enter. Remember, it's going to take a picture between those two little marks, and then I'm going to have it guess. And so it gives me a 0 of 4, okay? All right, so I'm going to go to the other one because there's 2 zeros. Second, calc, 0, press enter. I'm going to arrow over to the other side. I want to be on the left side of the 0, so right about there. Enter, and then I'm going to keep going using the arrow to the bottom. Enter, I want it to guess, and I'm guessing it's going to give me 5. So 4 and 5 are my zeros, okay? So time 0, time 4, and time 5. That also tells me that this was a factorable equation because those were whole numbers. Then it asks, at what time, what is the maximum height of the rocket, and how long does it take for the rocket to reach that height? Okay, so we know that if here's my rocket, the rocket went up, it started on the ground, went up, went down, and we know we had zeros at 4 and 5, okay? We were looking where it equaled 320, so we were looking for these two values here and here. So that was 4, that was 5. What's the maximum height of the rocket? Well, you have a couple ways you could do this. You could use the axis of symmetry and know that the vertex would have to be directly between 4 and 5. So it would have to be at 4.5, an x of 4.5. And then you'd have to find y from there, okay? So you'd plug in 4.5 into your function, and you get a height of 324. Or you can take your quadratic equation, this one right here, and you can find the vertex. You can do negative b over 2a, which would give me negative 144 all over 2 times negative 16, which is 144 over 32, which is 4.5. Again, you could use the two values you just got because you know the vertex has to be in between them, or you can use what you know about finding the vertex from standard form. You'd plug in 4.5, and again, you get 324. So notice this question didn't ask you for the x-intercepts. It asked you for the maximum height and how long to reach the maximum height. So just be careful to remember, x would be how long it takes to get to the maximum height, while y would be the height itself. So t and h. When will the rocket hit the ground? That's when h of t is equal to 0. So you're going to go ahead and set the function equal to 0. And solve. Again, that's a factorable equation because there's no constant terms, so you can just factor out. You can either factor out the negative 16 or divide by negative 16, just factor out a t. But if you go through that process, you can go ahead and do that now. Press pause and come back. If you're back, then you should have gotten a t of 9. So the rocket will hit the ground after about 9 seconds. Now, another way to think about that is the rocket left the ground, went up to a maximum of an x of 4.5, and since it started at the origin to get to the x-intercept, it would have to go the same distance, which would also give you 9. So there's lots of ways to think about this problem. And so I want you to really consider all the different ways the graph can help you solve the problem, okay? All right, now in that case, that will not always be true. If it doesn't start on the ground, then my initial height is a little bit higher, and so you couldn't just double your vertex, but in this case you could. All right, guys, hopefully that was a helpful video. Have a great day.